Part 3 of section 16.7, and we're going to look at an example now. We'll actually look at exercise number 21 from the end of section 16.7. Here we're given the vector field x z e to the y I minus x z e to the y j plus z k, and S, the surface, is the part of the plane x plus y plus z equals 1 in the first octant. With downward orientation. And we want to find the flux of F across S. So letting x and y be 0, we get z equals 1, and doing that for all pairs of variables, we can find that the intercepts of the plane are at 1, 0, 0, 0, 1, 0, and 0, 0, 1. So let's see here. So here's our surface S. And I won't attempt to draw this field, but we're trying to get the flux of F, the downward flux of F across S. Well, this is a case where Z is a function of X and Y. So Z equals 1 minus X minus Y. So that's what we earlier called G. And so we can use this formula in our computation. Remember that when we have this special case, upward orientation would be n equal to minus g sub x minus g sub y 1. Downward, therefore, is n equal to g sub x, g sub y minus 1. And so this is the one that we want here. So for us, the partial of g with respect to x is minus 1. Partial of g with respect to y is minus 1. And then k is minus 1. We're integrating over this region in the xy plane. this is the line y equals 1 minus x. And so we could go through the region like so, from x equals 0 up to x equals, I'm sorry, from y equals 0 up to y equals 1 minus x, and then x 0 to 1. So we can go 0 to 1, 0 to 1 minus x, and then we're looking to do f dot n dA. So then that is, I want to, guess I'll just go ahead and, so f is xz e to the y minus xz e to the y z, and then dot minus 1, minus 1, minus 1, and then this is dy dx. So 0, 1, 0, 1 minus x. This is minus xz e to the y. This product here is plus xz e to the y, and then minus z. Of course, we don't really want z here. It's okay that I had it here, they canceled out, but z is 1 minus y minus x. So this is minus 1 minus y, or 1 minus x minus y. Dy dx. So these cancel out. Integral 0 to 1. Integral 0 to 1 minus x. What I'll do is I'll just distribute this, and I'll just call this the integral then of y plus x minus 1 dy dx. And I shouldn't really bother you with this. You can verify on your own time that that comes out to minus 1 over 6. All right, so that's one that I guess wasn't too bad. We only had, the surface only has one side to it, and we had to remember that we were giving downward, or given to compute downward orientation flux. Now the fact that the flux of the downward flux across S is negative, what that really tells us is that the net movement is in the opposite direction. So had we computed the upward flux across S, we would have got positive 1/6. Okay, we'll come back and look at more later.